Hey everybody, today's lesson is over simplifying radicals with variables. These variables are going to be underneath the radical sign, so we're going to have variables in our radicand. So as a refresher, let's go ahead and talk about simplifying radicals. We did this the first week back, so let's go ahead and do the square root of 44. Now, remember that the square root of 44, we need to look for our perfect squares. Remember, 2 times 2 is 4. 3 times 3 is 9, and we're going to keep going until we get as far as we can go. So of the perfect squares listed, we're going to cross out those that are the highest. So the 49 and up is higher than our 44, so we can't use those. However, we can break this up, so 36 does not divide into 44 evenly. 25 does not, 16 does not, 9 does not, but 4 does. 44 can be broken up into the square root of 44 times the square root of 11. We know that the square root of 4 is 2, so our answer is 2 square roots of 11. Alright, for our next problem, we have 3 square roots of 80. Okay, now this is a little bit different because we have a number out front called a coefficient. Okay, so you may want to make note of that. Coefficient. A coefficient is a number out front. It cannot be a variable. It's a number out front. Okay? So we have 3 times the square root of 80. So let's break down the square root of 80. So we're going to need our list of perfect squares. Here we go. Put that down there. Actually, I'll move this up here. Here we go. Okay, so let's break down 80. Let's cross all the numbers greater than 80, so we don't need any of these. So does 64 divide into 80 evenly? No. 49, not so much. 36 does not divide evenly. 25, so it's 16. Okay, so the square root of 16 times the square root of 5 is going to give us 80. So the square root of 16 is 4. So what we have here, we can't forget our 3, is we have a coefficient of a 3 times 4 times the square root of 5. So this simplifies to 12 square root of 5, and that is your final answer. A lot of times people will make the mistake of forgetting about their coefficient. That is going to be the biggest mistake that people make. So keep that in mind as you're working on the problems. Alright, so now let's get to the part where it's the variables. So we're done with the review, let's move on to new stuff. Alright, so what we have here is a square root of x squared. Remember that the square root and a square are inverses of each other. So what's going to happen is the square root and the square cancel each other out and we're left with x. Now, in the case over here at the square root of x to the 4th, we can actually break up the x to the 4th into x squared times x squared. Okay, so what we have here is x squared to the 2nd power, and we're square rooting that. So remember with your properties of exponents, so this is why we didn't talk about this until we hit properties of exponents. So the square root and the square are inverses of each other, so we get rid of them and all that's left over is x squared. Now, here we have square root of x to the 3rd power. Okay, this one is odd. So this one's going to be done a little bit differently. Okay, and when I say odd, I mean it's an odd number, x to the 3rd power. So what this really is this is x to the 2nd times x to the 1st. Remember that properties of exponents allow me to add the exponents, and to say 2 plus 1 is 3. So I'm doing the opposite of what we learned in the last video. Now I can break this up in the square root of x squared times the square root of x. So square root of x squared, we did that over here, we got x. So this becomes x square root of x. So in the case of even numbers, we're going to have the radical disappear. So if we have an even exponent of a 4 or a 6 or 8, the radical will not appear as our final answer. However, if we have an exponent that has a 3 in it, we're going to have something left over. That's because it's odd. I can pull out 2, but 1 is left. Alright, so now let's work a problem where we have our variable and our number just like what we did in the beginning. So we're going to combine these two ideas now and solve this problem. So the first thing I'm going to do is I'm going to break it up. I'm going to put 121 in its own radical sign. I'm going to put p to the 20th power in its own radical sign. Now, the square root of 121 is simply 11 because it's a perfect square. 11 times 11 is 121. Now we have the square root of p to the 20th power. I can actually break this up to p to the 10th power raised to the 2nd power. And what we know about square root and the 2nd power is that they are inverses of each other, so they go away. Now, the reason I know that it's p to the 10th and then raised to the 2nd power is, remember that properties of exponents tell me to multiply this. So this becomes p to the 20th power. All I'm doing is the opposite of what we did in the last video. So now that we know that p to the 10th squared and square root, I am left with p to the 10th. So our final answer is 11 p to the 10th. All right, so here's our next one. Square root of 49 times the square root of a to the 6th times the square root of b to the 4th times the square root of c to the 8th. Now, the problem originally looked really awful and really long. So what we're doing is we're actually breaking this up into individual pieces, and we're handling it one piece at a time, okay? I don't give you, when you were growing up, your parents didn't give you a steak and say, here, swallow it whole. They cut it into pieces that you could manage. So that's exactly what we're doing here. Cut it into pieces that you can manage. Now the square root of 49 is a perfect square, so that's 7. Okay, the square root of a to the 6th is really the square root of a to the 3rd power raised to the 2nd power, because 3 times 2 is 6. Okay, the square root of b to the 4th is b second to the 2nd, and c to the 8th is really c to the 4th power to the 2nd power. So what we have here is that the square roots and the squares, because they're inverses, go away. So I'm left with 7, a to the 3rd power, b to the 2nd power, c to the 4th power. And that is the final answer. All right, so what I'd like for you to do for this particular problem is pause it and try it on your own. All right, so hopefully you already have the problem done. You paused, and now you are checking your work. So let's go ahead and begin by breaking this up. Let's take this steak and cut it into manageable pieces. All right, so now what we're going to do is we're going to work on each piece. So the square root of 400 is 20. The square root of g to the 40 is g to the 20 to the 2nd power. The square root of h to the 26 would be h to the 13th to the 2nd power. And the square root of I would be 18 to the 2nd power. All right, so what we're going to do is the square root and the square inverses, so those go away. And I'm left with 20 times g to the 20th, h to the 13th, and I to the 18th. And there we go. Okay, so in all the previous problems that we've had perfect squares and even exponents. Let's work on a problem that doesn't have either of those. So let's begin, first off, like we always do, breaking this problem up into easier pieces to work with. So 75, the largest perfect square that goes into 75 is 25. So we have the square root of 25 times the square root of 3. So this becomes 5 square roots of 3. Over here we have p to the 22nd. That's going to be p to the 11th to the 2nd power. That is going to be p to the 11th because the square root and the square cancel. Q to the 8th is going to be the square root of q to the 4th to the 2nd. So we're going to be left with q to the 4th. And last but not least, r to the 21st. The problem with this is that we need to have r have an even exponent. So we're going to have r to the 20th times r to the 1. And the reason for that is I can add these exponents. 20 plus 1 is 21. I can change r to the 20th. So let's go ahead and break this up so that I can handle r to the 20th. Now I didn't put a 1 exponent here because it's understood. You don't have to do that. So r to the 20th is really r to the 10th to the 2nd power. Okay? So all of this simplified is going to be r to the 10th square root of r. So now we have to take each of the simplified pieces and put them together. You'll notice that in the first one we've got a square root of 3. In the last one we have the square root of r. So in our final answer, I'm going to scroll down a little bit, we're going to have 5 p to the 11 q to the 4 r to the 10. Now I put all of the ones that were outside of the radical sign out front, and then a square root of 3r, because 3 is under the square root and so is r. So this right here is our final answer. Now because we had an odd exponent, okay, we are going to end up with a square root left on the end for our final answer. Okay, so that's something to check as you're working. Now, we're going to do one more problem, but before we do, I want to throw in something for your pop quiz. There are 2 clubs here at River Ridge that I sponsor. The first of those is the Games Club, and we meet Mondays after school in my room playing video games. And I also have the Coding Club. Okay, so if you are interested into programming, you can hang out here and work on my computers. Okay, so those are the 2 clubs that I sponsor. So take a note, write that down, and you can use your notes tomorrow for that pop quiz. Alright, so what I'd like for you to do is go ahead and pause this video and try this problem for yourself, keeping in mind this is an odd exponent. Alright, so once it's broken up, we can work on each piece. Square root of 64 is 8. This is m to the 4th to the 2nd. This is going to be the square root of n to the 2nd times n to the 1st. And this is going to be the square root of p to the 11th squared. So put this 8 down here. So what we have is now we can simplify each piece. So square root and square inverses. So this is m to the 4th. Okay, n squared, and the square root of that would be n. And we're going to be left with this piece. So hang on to that for now. And the square root of p to the 11th power squared is p to the 11. And don't forget, you got to have this square root of n. Remember, the radical sign will always go at the very end of your answer. So there you go. All right, that's it for today. I will see you guys later.